Okay, so shall we? All right, so now we have done with separable equation. We have done with homogeneous equation. Okay, so today we're going to proceed with this exact equation. Okay, can you see my screen here?
Yes.
All right, so exact equation. So this is just another type of ordinary differential equation where we call it as exact equation here. So how can we identify exact equation? All right, so this is quite longer compared with the previous type or where for which this exact equation has two types of method of solution, but both method are acceptable. Okay, so now how can we identify that ordinary differential equation is exact equation? Suppose we have function of f(xy) equals to negative m over n. So this function is a function of a fraction m over n. Okay, therefore the first order differential equation is given by this. So this fxy is actually dy dx. So suppose dy dx equals to a fraction of negative m over n. And if we rewrite this function, what's wrong? Sorry, I have a problem with my laptop. Yeah. Can you hear me? Can you see my screen?
Yes.
Okay, sorry. No problem. Okay, now next proceed. Okay, so now suppose we have a function. Okay, again, suppose we have a function of fxy where that fxy is dy dx, and the function is represented by a fraction of negative m of n. Okay, and then we can rewrite this as m xy with dx plus n xy with dy equals to 0. So if we can rewrite the differential equation in terms of like this, okay, then we can call it a Z equation if del m over del y equals to del n over del x. Okay, let's take a look at the example. So first example for a Z equation, we have what? Okay, can you see? So now,
Yes.
as you can see here, it is already written in terms of a function of x and y together with dx and a function of x and y together with dy. So for those with dx, it is a function of m. Okay, just take a look at the definition. And for those with dy, so let's assume that it is n. Okay, now this differential equation is said to be exact if we can differentiate m with respect to y, and then if the product of this differentiation is equals to differentiate n with respect to x, then we can say that it is exact. So now we have m equals to 2xy plus 3. Right, so del m over del y, differentiate m with respect to y, we will have what?
2x.
Okay, 2x. And then we have n equals to x squared minus 1, and we differentiate n with respect to x, we have
2x.
2x. So now, as you can see, del m del y equals to del n del x. So if these two are equal, then we can say it is a Z equation. Okay, so that is how you identify whether that differential equation is a Z. So you clarify what is your m, what is your n, differentiate m with respect to y, and differentiate n with respect to x. If both are equal, then we can say that the equation is a Z differential equation. All right, clear? So that is the condition on how can we identify the function is a Z. So then how can we find the solution of this Z? So we have two methods here, method 1 and method 2. Okay. Let's do it together with the example one by one. Method 1 first. Okay, let's proceed with method 1. So first, write the differential equation. Okay, we have already got the differential equation written in terms of m dx plus n dy equals to 0. All right, so we have here 2xy plus 3 dx plus x squared minus 1 dy equals to 0. And it is proven that this is exact. Okay, settle with those parts. And then if the dE is exact, okay, now you know that this differential equation is exact equation. So we have m equals to del u del x and equals to del u del y. Meaning that you know what is your m, you know what is your n, and you have proven that del m del y equals to del n del x. So actually, we can write this mxy here, which equals to 2xy plus 3 equals to del u del x. And n, which is equals to x squared minus 1, is now del u del y. So we identify what is our del u del x here and what is our del u del y. So we just create this del u del x out of m and del u del y out of n. Okay, clear. So now we have your ux, we have your uy. Then to find uxy, integrate 1 with respect to x. Okay, so this is your 1, this is your 2. So you have del u del x equals to 2xy plus 3. You have del u del y equals to x squared minus 1. This is the first equation, this is second equation. Okay, so now in order to get the solution out of this del u del x, del u del y, of course we can have uxy as our solution. So this uxy is come from integrating del u x, integrating m here with respect to x. So integrate what? Integrate 2xy plus 3 with respect to x. Okay, so we have what? So we have here uxy equals to integrate with respect to x. You have
x squared y plus 3x plus psi y.
x squared y plus 3x plus
Psi y.
psi y. This is your constant. Okay. Just before this, we integrate with plus with c. Now we plus with psi y. Why? Because here we integrate with respect to x. So we just assume that the constant should consist of another variable of y here. Okay. And then what? To determine psi y, differentiate 3 with respect to y. So this is your third equation. Okay, differentiate this uxy with respect to y will give you del u del y. Differentiate with respect to y. We have what here?
X squared plus
X squared
psi prime y.
plus psi prime y. And this is del u del y. This is del u del y. And then what can you do here? Compare del u del y that you obtain here with the second equation. So this one we have x squared plus psi prime y. Another one we have x squared minus 1. So what can you conclude from this comparison?
Equals to -1.
Okay, so you can conclude that psi prime y equals to -1. So if psi prime y equals to -1, what is psi y? Phi y?
Negative y plus b.
Okay, just integrate -1 here with respect to y. So you have negative y. Okay, understand? So no need to plus with constant because at the end you will put all constant together also. So just let it be. Okay, so now you have your psi, you have your phi y here. Okay, so your uxy equals to x squared y plus 3x minus y. And then, okay, we have done this one. Okay, we have done this one. Write down the solution in the form of uxy equals to a. So uxy equals to a, meaning that x square y plus 3x minus y equals to a. So all constant that we have obtained in the calculation, we accumulate that into this a. So this is the solution of a z equation by using method number 1. Okay. Understand or not? Anyone ask question?
Doctor, may you briefly explain again the whole process, just to digest again?
Okay, first, all right, let's do this together. What is our first step? You have to make sure what? Your first step is to make sure it is a z. Okay, your first step is to make sure it is written in terms of a function of m and n equals to 0. Okay, now it is written like this, and then you have to make sure it is a z. Okay, this is the second step, a z equation where you prove that del m del y equals to del n del x. Right? And then once it is a z, once it is proven that it is a z, you can say that your m is actually du. This is your third step. Your m is actually du. Your m is del u del x. Your n is del u del y. Okay. The third step here is to equate this m and n with del u del x and del u del y respectively. Okay. All right. And then the next step is we want to find the solution. Okay. In order to find the solution, remember this is in terms of del u del x, del u del y. So your solution should be uxy, where you can integrate del u del x. Okay, integrate del u here with respect to x, and then you get uxy. Actually, it can either integrate del u del x or integrate del u del y. You just can reverse the process of comparison here. Okay, so now you integrate del u here with respect to x, and then you get your uxy. Okay, so once you get your uxy, again differentiate. What is differentiate the function that you obtain, which is u here, with respect to y, because you want to compare with another one, del u del y. If you integrate the first equation, del u del x, then for this part you differentiate del u del y because you want to compare with this. Okay, so now you differentiate del u with respect to y, and then you obtain here, from here to here you differentiate, you obtain x squared plus 5 prime y here, compare with second equation. Okay, once you compare, why we want to compare? Because we just want to obtain the value of phi here. Okay, compare, and then you obtain the value of phi y here, and then last one, you just substitute what is your phi in here. Once you identify your phi, substitute again, and this is your u. So lastly, equate them to a constant. Then this is your final answer. Okay, is that clear for method number 1? Any question?
Better understanding. We'll try to digest again.
All right, good. Okay. So shall we proceed with second method by using the same example? Okay, so now let's proceed with second method here. Okay, what is our question again? 2xy plus 3 dx x squared minus 1 dy. Okay, of course, first step, what is your first step is to make sure what is your m, what is your n, and prove its exactness. Okay, once you prove its exactness, then you know that del m del y equals to del n del x. So now this is your m, right? And this is your n. So this is your first method, exactness. Once it is proven, then you can say that your m is equals to del u del x, same with the previous one, and your n is equals to del u del y. Okay, same process with the previous one. You prove the exactness, you identify what is your m, what is your n, you prove the exactness. Once it is proven, then you can say that m equals to del u del x, n equals to del u del y. So now del u del x is 2xy plus 3. Del u del y is x squared minus 1. Okay. Until here, right? So now we want to find the solution of u. Okay. So for this method, you integrate both. In order to find uxy, you integrate the first and second equation. Okay. Where the first one is you integrate 2xy plus 3 with respect to x. And for the second u, you integrate x squared minus 1 with respect to y. Okay, so integrate this, you will have what? Again?
X square y plus 3x plus psi 1y.
Okay, plus this one, psi y. And then another one here, you should get
X square y minus y plus psi 2x.
minus psi x. Okay, so the difference here is this one. Okay, psi 1y, psi 2x. So actually, these two are all uxy, right? So what should you do to get psi y and psi x here is you have to compare. Compare 3 and 4. So this is your third equation. This is your fourth equation. Okay. Compare 3 and 4 to get the value of psi y and psi x. Okay. Now how can you compare? Just equate them together. So x squared y plus 3x plus psi y equals to x squared y minus psi x. So
Isn't
as we
it
can,
supposed to be positive psi x?
sorry, yes. Okay, then you compare. How can you compare? This one is x squared y, x squared y. This one is 3x, this one is y. This psi y is a function of y. So it equals to what's left here? Negative y. Okay, and then another one, psi x is a function of x. So this one equals to 3x. Then just substitute. So your uxy equals to x square y plus 3x minus y plus 3x. Sorry. Okay, we have 3x here. All right. And then the final answer should be written in terms of uxy equals to a. So uxy equals to a becomes x square y plus 3x minus y equals to a. Okay, so for this case, once you've got your phi y and phi x, you just can choose any function that you want as the answer. Is it third equation or fourth equation? If you choose third, then you just substitute psi y. If you choose fourth, then you just substitute psi x, because both equation will give you the same function. Is that clear? So your answer from method number 2 and method number 1 should be equal. Okay? Anyone has question? Method 2 is easier because you integrate both and you compare. But sometimes the function that you choose is cannot be integrated. That's why you have to do it one by one. Starting from here, integrate first. Once you got the function, then differentiate again, compare with the differentiate function, and then find the constant. But for this case, you just can integrate both and compare to find the constant value. Is that clear for method number 2? Anyone has question? So this is how we can find the solution of a Z equation for ordinary differential equation. We have method 1, we have method 2, and we have the process of how to prove the exactness of the equation. Okay. All right, let's try the second example. Okay, we have done with the first example, right? Solution of method 1. Second example, solution of method 2. Okay, notice that from the note, some non-exact can be turned into exact by multiplying it with an integrating factor. So what is the integrating factor? Okay, we can try the next example here. Okay, first, try to show this given equation is not exact. Try to show the given equation here is not exact. How can you show? You have to make sure this is not fulfilled. Del m del y equals to del n del x. Okay, what is your m and n here? You know that your m is a function together with the x and your n is with the y. So your m is what? First, identify what is your m, what is your n. And then make sure del m over del x equals to del n over del x. So if these are not equal, then it is not exact. Right? What is your m and n here?
M is xy plus y squared plus y.
Okay, xy plus y squared plus y, and then n is x plus 1. And then differentiate n with respect to y, differentiate n with respect to x, and then check whether they are equal or not. This one. What is your del m del y?
X plus 2y plus 1.
Okay. X plus 2y plus 1, and del n del x?
1.
1. So means that they are not equal. Okay, so it is not exact differential equation. So how can we find the solution of this non-exact? Okay, from the note, it is mentioned that if we use an integrating factor, okay, so this non-exact can be turned into exact by multiplying with an integrating factor. So now it is mentioned here, by multiplying both sides with the integrating factor of exponent x, solve the equation. Okay, so now we just multiply the function given here with exponent to the power of x. So we have ex okay, plus ex, x plus 2y with respect to y equals to 0. So from here, you can see that m is ex, xy plus y squared plus y, and is ex, x plus 2y. Okay, and del m del y, we can prove that del m del y is what? Del m del y is ex, x plus 2y plus 1, and then del n del x is ex, x plus 2y plus ex, which equivalent to ex, x plus 2y plus 1. So now del m del y equals to del n del x. So it is exact. Okay, this one just differentiate this by using what? Product rule, right? Differentiate again, and then you check again. Now both are equal, so it is exact. Then we can find the solution. How can we find the solution? Okay, so as you can see here, this is your m, right? And this is your n. So we can write your m as del u del x equals to exponent x, xy, y squared plus y. And then another one is del u del y equals to exponent x, x plus 2y. So method 1 or method 2, which one do you want to use? Both are doable, but somehow, as you can see here, method 1, you just can choose which function that you want to integrate. And for method 2, you integrate both and you compare. But for this case, can these two function is quite easy to integrate? Or you just can choose any function, just integrate one and compare with the differentiation process after that. Any idea?
Method 1.
Method 1 is easier, right? Because you just need to
Yes.
integrate one function. So which function that you want to integrate?
Du dx.
du dx or du dy?
I think both are okay.
Both are.
Just the dy maybe faster a bit.
Yes, right. So let's choose the faster one. Okay. So why don't we choose this one? Because it's quite easier to integrate. Okay. So uxy equals to integrate exponent x with respect to y, right? So this one becomes what? Dx x dx y, right? And then this one becomes
Yes, y square.
dx y squared plus with
Sine x. Sine x.
yes, sin x, right? And then what? Then differentiate with respect to
X.
okay, differentiate with respect to x because you want to compare with del u del x. So what is your del u del x from here? Right, everyone got this?
Yes.
Okay, just simplify. And then you compare with del u del y. Compare with star here. Okay, and then you can see here exponent x. So what is psi prime y here? S psi prime x here.
0.
Right, 0. So psi x equals to integrate
0
0.
plus constant. 0 plus constant.
So constant. Okay, so psi x equals to constant. Then what is your uxy? Just substitute, right? Ex xy plus y squared plus with c. And the final one should be uxy equals to a. So ex xy plus y squared equals to a minus with c. Right, we just put constant together and we can simplify this with another variable as k. So ex xy plus y squared equals to k. So this is your final answer. Is that clear? Understand or not? What is our first step? First step is to prove the exactness. Second step, by using method 1, we integrate. We integrate this, we get u and then we differentiate, and then we compare. After we compare, we can find the value of psi prime and psi x there. Once you have the value, you substitute again and equate them to a constant, and then this is your final answer. Is that clear? Any question? Anyone got question? Yes. Which method that you want to use is up to you, and it's up to the function. You decide whether that function is suitable enough for method 1 or method 2. Okay? There is there is no right or no wrong on which method, but somehow if you choose the wrong selection of method, the answer is not wrong, but maybe the solution is quite long compared to the other method because of the process of integration, the process of differentiation there. Right? Are we clear? For this exact equation, the solution is quite long, but as long as you understand, it should be doable.
Doctor,
Yes?
can I ask about the first order homogeneous equation for the final answer, final solution? In what form should we write? Is it we must make y as the subject, or it can be x as the x as one of the variables on the left hand side?
Okay. If the function is doable for simplification process, the right way is the right way we can write is y equals to something, right? Because y is dependent variable. But if the function is quite complicated for you to simplify, just leave it like that. Okay?
Oh, okay, understood, doctor. Thank you.
Okay, why don't you try the question from past year, the first question here for exact, give you around this one. Or you just can refer this question to your notes, and I just display the process here. Can you? So that you can refer to the notes that we have discussed. Look at the question past here, the first question, find the general solution there. You have your notes together with you, right? This one. Find the general solution of the following exact. Okay. Take note on this one first, where the answer is. Okay. Done. Then just I'm going to display this method. So for you to refer this. It's quite long, right? Tengok sini dulu. If you have question, you can ask. Okay, try. I give you around 10 minutes. All right, got it?
Yes.
Okay, good. So I hope you can try the rest of the question there. Let me give you the answer for you to try before we proceed with the next differential equation. Okay, this is for first equation answer, and you can try the tutorial. If you have question, you can ask. Right, take note first on this part. And we're going to proceed with the next type of differential equation. Can we? All right, done with this one. Okay, so now the next one is linear equation. Are we ready? Okay, so how can we identify? Right, we have done with separable, we have done with homogeneous, and also the exact. So for this linear differential equation, how can we identify that differential equation is linear? Okay, so before this, we have done with how we identify the linearity of differential equation, but this is first order, so we just have dy dx. There is no d squared y over the x squared, d cube y over the x cube, and so on. Okay, so for this first order linear differential equation, it can be identified by looking at the general form here, where the coefficient of dy dx must be 1, and there is a function together with y here equal to a function of x. Okay, so px and qx are a function in x. Okay, now let's take a look at the example. We have dxy okay, so this is from example 1 from your notes. Okay, we have the coefficient of dy dx here with 1, a function of x together with y, and a function of x here. So this is the coefficient, and this is what? Comparing to the general form, this is a function of p, and this is a function of q. So you can identify what is your p and q here, right? Okay, so from the notes, determine P and Q there. You just can write down them as x equals to what? 1 over x, 1 over x plus 1, qx equals to exponent x over x. So it is important for you to identify P and Q, because this P and Q, we're going to use it to find the integrating factor and find the solution after this. Okay, so now determine the value of P and Q such that the coefficient of dy dx is 1. So done with the first step. Okay, so you have identify your P and Q. Second step is what? Calculate integrating factor. So what is integrating factor? So integrating factor known as mu x is equals to exponent integrate of px dx. So your mu x for this case equals to exponent to the power of integrate px is 1 over x plus 1 with respect to x. So integrate 1 over x becomes
ln x.
ln x. Integrate 1 becomes
X.
x. Right? So you can simplify this exponent ln x
Ex.
times with ex. So exponent ln x is
X.
x exponent x. So this is your mu x. Okay, so this is your second step. And what is your third step here? Okay, your third step, write the equation in the form of d dx mu xy mu x qx. Okay, where you just can write this as mu x y equals to integrate mu x qx with respect to x. Why integrate? Because the general form is differentiate mu x y equals to mu x qx. Then we just omit this this differential d over dx here with the integrate sign. So mu xy equals to integrate mu x qx dx. So mu x is x ex. Y is what? Y is y. Integrate mu x ex. Qx is ex over x. Integrate with respect to x. So this one is x, this one is x. So you just integrate exponent to x here. Okay. So your answer should be
1 over 2x plus 8.
okay, x e x y equals to exponent to x over 2 plus with the constant. So y equals to 1 over x ex multiply with exponent to x over 2 plus with c. Okay? And you just can simplify y equals to, final answer y equals to this one ex, this one e2x. So ex over 2x. This one is c over x dx. So this is your y. Okay, understand or not? This one, the last one, you just put y, 1 over mu x. So this is your mu, just put it here, integrate. So this is the product of integration that you have obtained. Okay, so first, you make sure that it is written sequentially in the form of dy dx. Make sure the coefficient equals to 1, pxy equals to qx. Then you can identify what is your ex, what is your qx. Second step, find integrating factor. Once you obtain your integrating factor, just substitute to the mu xy equals to integrate of mu x qx with respect to x. And then solving this, you can find what is your y. And this is the final answer. Is that clear? This is for linear equation. Anyone has question? Easy, right? Again, from the note, as you can see, non-linear can be converted to linear by using the right substitution. Okay, let's try the example for non-linear. How can we reduce the non-linear to linear before we find the solution? Example 2. Using z equals to y square, convert the following non-linear into linear. So you know that this is non-linear. Solve the linear equation. Okay, how can we convert? Okay, first, you need to create the dy dx from this z. Right. So z equals to y square. So dz dx equals to 2y dy dx by implicit differentiation. Then dy dx equals to 1 over 2y dz dx. Okay, this is your first step. Use the substitution. Okay, then substitute to the problem. So now you have x square y dy dx, okay, minus xy squared equals to 1. Okay, so this one we have y dy dx. So here we just can have, put the y here to the left hand side, y dy dx, right? Equals to 1 over 2 dz x. So now x squared y dy dx is 1 over 2 dz dx, right? Minus with xy squared, and y squared is z, equals to 1. Okay. So now you have here x squared over 2 dz dx minus xz equals to 1. So in order for the differential equation to be linear, what you should check first, the coefficient of dz dx must equals to what? 1. So you have to make sure this one should equals to 1 here. Okay. Then just multiply with 2 over x squared. So everything here multiply with 2 over x squared. So you have dz dx minus 2 over xz equals to 2 over x squared, right? Just simplify the function. And you can see here, the coefficient now becomes 1. And this is a function of x with z. And this is a function of x. So can you determine what is your P and Q here?
Negative 2 over x is px.
Right, so
2 over
px
x minus qx.
Okay, good. Once you have your P and Q, what is your next step?
Find the integrating factor.
Okay, how can you find the integrating factor? Mu x equals to?
E to the power of integrate px with respect to x.
Okay, try to find mu x here.
One over x squared.
All right, okay, good. 1 over x squared. So we just substitute integrate of p minus 2 over x. So this one is actually minus 2 ln x exponent ln x minus 2, which equals to x minus 2 1 over x squared. Okay, once you got your integrating factor, and then what? Mu x.
Find y.
Y equals to integrate mu x qx, and then you can find y. Okay, so just substitute all the inputs there.
Negative 2 over 3x cubed plus constant.
Okay, sorry, this is not y, right? This is z, because we have z here. So you have what? Negative
Negative 2 over bracket 3x cubed plus with constant.
plus with constant. Okay, that is your mu x, integrate mu x qx, right? All right.
Yes.
Okay, that one. Then just simplify to find z. What is that?
Negative 2 over 3x plus ax squared plus cx squared.
Okay. And remember, what is that? Just
Y squared.
Okay, so z equals to y squared. Then y squared equals to minus 2 over 3x plus cx squared. This is how you find the solution. Oh, not yet, because we have condition, right? So since we have the condition, then you can find the values of c, where you just substitute when x equals to 1, y equals to 1. So this one minus 2 over 3 plus c1 squared. So c equals to
5 over 3.
5 over 3. And then just substitute again. So your y squared equals to minus 2 over 3x plus 5 over 3x squared. So this is how you find the solution of non-linear. Okay, first it is non-linear, reduced to linear by using the substitution. Okay, simplify to obtain what is your P and Q. Find the integrating factor and then find the solution by using the function here. And remember, this is in terms of z, which is already substituted from the original problem. Just remember to change again the variable. And this is the final answer. Is that clear for linear equation? Alright, so from 1 to 10, where are you for today's lesson? How about the rest of you?
5.
5.
Because quite a lot of steps need to look again.
Yes, of course, you have to take a look again. And these are all given. These are all explained by me, right? You have to try it by your own after this. Okay? It's okay. This is the learning process. Don't worry.
Doctor, may you upload the recording later? Then we'll view it again later.
Of course, I uploaded all the recording session in the e-learning.
Okay. I mean to later.
Oh, all right.
Okay, thank you, doctor.
This one is for past year. I will share with you the past year question. Don't forget to try the tutorial. Okay.
Doctor, do you have the mixed tutor answer?
The tutorial has the answer, right?
Not all the
Yes,
questions.
not all questions, but some of it.
Not all.
Some application questions do not have answer for the back but second page.
Oh, okay. Okay, it's okay. You can try it first. If you have problem, you can ask. Right? What I want to do right now? Oh, the answer for this one. Search first. Okay, I hope you can try it first. If you have problem, you can ask. Okay, so next class, we're going to proceed with Bernoulli and also the application. Hope you can finish it. All right, so try to do it the tutorial first and then all the questions here. And if this is not enough, of course this is not enough, we just can refer to the past year's exam question, right? If you have problem, you can ask me. Okay, so before we leave, let me open the attendance links first. Oh no, I should stop the recording, right?